Hello everyone, this side Ankit Misra. Very good evening to everyone, and I hope I'm audible, right? So before I just continue, let me just share my screen, and I hope I'm audible to everyone. So anyone can confirm this, am I audible, guys? So that I'll continue. So right now we have 19 candidates connected. Hello Vaishnavi, Tejaswini, Taruna, Apisha, Priya, Anas. How are you, candidates? Okay, so how was your overall practice going on? Just let me know. Are you facing any difficulties or like issues? I have already shared my GitHub account, right? So I hope everyone is like practicing the same thing, right? So if you will face any kind of issues now, then let me know, okay? And in upcoming classes, I'm planning to give you some sort of data related to the company's aspect so you can practice the respected ML models as well, right? Now in current scenarios, na company generally interested to build ML model. And they just also want you to deploy the ML model as a website format as well. So what we'll do, whatever we are completing now, we'll try to build a website where user can particularly give a value or like inputs, and the model will predict that value, right? So let's just continue. And uh, my screen is visible, right? Just anyone kindly confirm me, right? So we have already covered this classification problem using machine learning, and the topic was logistic regression, right? So let me just first quickly run this all the notebook, right? And this one is the theoretical portion, right? We've started with the step one to import all the modules. We did some like practice related to the logistic regression, and it is completely based on the binary classification, zeros and ones, right? This one is the function, and it is just a dummy data, right? Where the user can buy the credit card or not, right? And we know that the mathematical equation is 1 upon 1 plus e raised to the power minus x. Why I am revising on day-to-day basis? Because these are the equations that generally been asked in the interviews, right? So step two was to load all the data set. We have already the data set at the given URL, guys. I have already shared this URL. If you again want this, let me just copy this URL. Well, I have already shared this notebook as well, right? So if anyone wants this notebook, let me just share it once again. This one is like for dataset URL. If you want to practice it along, you can do this, right? This one is the URL for dataset, and let me just share the notebook as well. Well, the notebook is already shared, right? If anyone wants to do the practice, they can do it, right? This one is the notebook URL. Now, so we have already covered multiple things like EDA portion. We have already built a ML model, and we also perform the problem related to feature engineering, right? Where we need to convert the textual data to the numerical one, right? And we have different ways to perform the feature engineering, right? This one is all about the exploratory data analysis. We built a model. We did some like exploratory data analysis part. The model building was there, and somehow we got the overall accuracy of 100%, right? Now we know that in binary classification we have some sort of different matrices, and the matrices are like specificity score, accuracy score, sensitivity. Sometimes we also say this sensitivity score as a recall score. A precision score is there, F1 score is there, confusion matrix is the main matrix, and with the help of this confusion matrix you can derive all these score, right? So whenever interviewer asks, it will generally ask you about the confusion matrix, because F1 score, precision, recall, and accuracy all can be derived with the help of confusion matrix, right? I was just telling ki inside the confusion matrix, we have two sort of possibilities. The first one is the actual answer, and the second one is the model answer. Let's just take an example. If the patient has the tumor cancerous is not, or if the patient has a tumor, if the tumor is cancerous, the model will say yes. If the cancerous tumors is actually in yes, right? So you can just say we are creating the kind of matrix where we are comparing the actual answer with the model answer, right? And the possibilities could be like four different ways. The actual answer could be yes, and the model answer also yes. The actual answer yes, and the model say no, it is my wrong output, right? And we know that the model can say wrong output two times, and same with the right output as well. So there is a confusion matrix that generally try to show the different types of like output, where the model gone wrong and where the model goes right, right? So you can simply call all the matrices. The matrices you can import from sklearn dot matrices, import all the matrices and scores, or like accuracy score. You can simply store this inside a cm. Cm is nothing, just a confusion matrices, and this one is the correct classification. whatever you are getting at this diagonal level is the correct classification by the model. And if you are getting any value apart from the zero, that means it's a wrong classification. And you have to be make sure in the practical scenario you are not going to always get a zero, right? Yes, guys. Any question? Is anyone saying some? Is there any question, Apeksha, or like anyone? Karuna, Vijay, or rest candidate? Okay. So in the practical scenario, you are not going to always like get this zero number. This zero is like because we have a like very clear or like structured data right now, and it's already neat and clean, right? So this the this kind of diagonal is the correct prediction, and this diagonal is a wrong prediction. Let me just take a screenshot, and then you will deeply understand this. What is that, right? So I'll go to the paint, and confusion matrix is the very important one, right? So what is that? This one is the correct classification by the model. So let me just circle out this with green color. This one is the correct classification, 5 and 12, right? And that one is the wrong classification, or you can say misclassification. If you are getting any values here, it means it is wrong classified by the machine or like the model that you have built. Since the accuracy score is 100%, it says right now we don't have any misclassification data right now. Okay. And that can be simply derived with the help of confusion matrix. Now we can simply turn out this confusion matrix into this kind of visual where the X label is like the model prediction. And we know that because this is the binary classification, so the possibility is only 0 and 1. 0 is like the customer will not likely to buy the insurance. The one is like customer will buy the insurance. Okay, so how to read out this? 12 customer actually they were buying the insurance, and model also say they will buy the insurance. So it's a correct classification. 5 customer they were not buying the insurance, and the model also say they will not buy the insurance. So it's like the perfect classification by the model as well. So it is a good classification, right? Now these are the wrong classification, and since all the values are zero, so we are not getting any misclassification right now, and that is the reason we are getting the accuracy of 100%. Now this confusion matrix gives you 4 different data, and we have to understand these 4 different data, and we have a nomenclature for that. So let me just show you what exactly this confusion matrix is, right? You can take a reference of this Google image, and this confusion matrix give you something like this: TN, FP, FP, FN. These are the four possible values, right? We know that the negative is 0 and the positive is 1. Again, the negative is 0 and the positive is 1. And this predicted is the machine values, and this actual is the actual value, right? Whenever we are getting the 0 0, it generally represented by the TN. TN is nothing, it's a true negative. Why we are saying this as a true negative? Because the result is negative and model has predicted its true value. Model is true here, right? Model has predicted the right value. That is the reason we are getting the true on both diagonal side. And why we are getting the negative side candidate? Because the value is 0. The customer will not likely to buy the insurance. That is the negative statement. So we are saying this as a true negative. Okay. Model also like predicted the true negative, and actual it was also the true negative. That is my perfect classification. And the another perfect classification I'll get is the true positive. Why we are saying this as a true positive? Because the actual 12 customers said they will buy the insurance. It was like the positive value. And the model also said this like they will buy the insurance. So it is a true result. So that is the reason you are saying this as a true positive. So this matrix or like this confusion matrix can be divided into 4 quadrant. This first and fourth quadrant is generally referred as a true negative or like TN, and the fourth one is the true positive is like the TP, right? Now we have 2 different false classification, and that is the reason we are taking this as a F and F, the false negative classification and the false positive classification. If we are getting any value inside this quadrant, it means this is the misclassification answer by the model. So we have to minimize all these false classification. Right now we are getting 0 false classification, and that makes our model a perfect model or like 100% accurate model, right? But in the practical scenario, we are not likely to get the zeros always. Okay, I hope everyone is getting my point, right? You can just simply check now. You can just go to Google and you can just take a reference of this like confusion matrix scikit-learn documentation as well, right? And here you can check. If I just click on this, in this dummy data, I'm just getting TN as 2199 value. It's like a true negative classification, 69 as true positive classification, and 182 as false negative classification. We know that this category is a false negative classification, and this category is called a false positive classification. Is that clear, candidate? Let me know in case of any doubt. If it is clear, let's just. Are you getting my point? Sir, screen is not visible. Guys, I have already shared my screen now. You can just check. Candidates, my screen is visible or not? Can anyone confirm me? Apart from this Taruna, Apeksha, Vaishnavi, and rest candidate. Let me just share my screen again. It's sharing or like my, it is showing the collab interface. It's visible but not live. Okay. Oh, that's a big issue, right? Let me just share my screen first. I've explained multiple thing and the screen was like freezed, I think. Hai. Let me just share it again. Now just let me know. Again, I am sharing my screen. Candidate, I'm sharing my screen and this one is the confusion matrix. Just let me know is that visual or not, right? Okay, so I was just telling, got it, Sarath, right? I was just telling this one is the confusion matrix and all these diagonal values are like the true classification. The first one is negative and the second one is positive. That is my true negative and true positive. Okay, and all these diagonal are likely the false classification. And why we are saying this as a false negative? Because this has a negative prediction and this one has a positive prediction. But the model prediction is false. That is the reason we are saying this as a false classification, right? Now, in the practical scenario, we'll get the multiple values that can be fall inside this quadrant, right? But the model has to predict the values inside this quadrant only. And if we are getting the values from this quadrant only, it means our model is perfect, right? Likewise, I'm getting right now. Okay, 0 0 is like we have a zero misclassification right now. Okay, now let me just take a screenshot of this. And we know that the first value is called TN, second value is called FP, third value is called FN, and fourth one is TP, right? So what you will do, candidate, you can just simply turn out this array into a flattened array. Why we are flattening this array? First of all, let me just paste this screenshot. If you want to paste the screenshot now, you can just click on this text option and you can have a copy of this image. Just go to this markdown and press Ctrl V and then Shift Enter. Now you'll get the overall nomenclature of confusion matrix. What is TN, what is TP, FN, and FP? And we know that TN is nothing, it's a true positive. Okay. TN is true positive. Uh, TP is true positive, right? And TN is true negative. And same case with the FN. FN is false negative. And FP is false positive. Perfect. Now let's just pick the confusion matrix and try to get the values from it. What is my TN, FP, FN, and TP? Okay. If I just simply convert this CM into a flattened array, and we know that we have a method for that, np.flatten. Let me just flat this, right? And this is like 5, 0, 0, and 12. And we know that this 5 is nothing. It's a TN value. It's like a true negative value. So can I unpack this? Can I say this one is like my TN and the second one is this 0 and this 0 is nothing. It's a FP. So let's just write this as FP. And the third 0 is nothing. It's the FN. So you can just say FN. And the fourth one is like the TP. So you can just simply say this as a TP. And what you can do, you can just copy this code and that makes this cm.flatten into unpacking kind of thing, right? And once you run this, you have completely unpacked this cm.flatten. Now you are getting the multiple values like TP, FP, FN, and TP. Okay. Now we have a formula for each scores. Well, in generally, the interview will not going to ask you what is the formula of recall score, what is the formula of accuracy score, like the F1 score, sensitivity score, and so on. But for a practice thing, you need to understand the formula, right? So first of all, let's just start with the accuracy score, right? The accuracy score is like where the model able to predict the true value. And we know that the true value are like TN and TP. So you can do one thing. If you want to print this accuracy score, let me just write this as ACC score, because we have already built-in function to just calculate the accuracy score. So because we are calculating with the help of formula na, and that is the reason I am just writing this as a ACC score, right? The ACC score or like accuracy score say pick the correct classification, and we know that we have two correct classification. The first one is true negative and the second one is true positive. So you can just simply add up the value TN plus TP, and then simply divide it by the all classification value. And we know that we have four different classification: TN plus FP plus FN plus TP, right? So you can just simply write the TN plus FP plus FN plus TP. Once you solve this, now we are getting all these value, we are getting all these value because of this confusion matrix. And that is the reason I was saying confusion matrix is the important one, because with the help of confusion matrix only you can get all the TN, TP, FP, FN values. And once you got this all values, you can calculate any of the scores, because all these scores are based on these formulas, right? And you can just simply print this accuracy score. Accuracy score is, and you can just print this ACC score, right? And you're getting the accuracy score as 100%. You no need to write down this formula, because we have already calculated this score with the help of model.score. Model.score also gives the accuracy score. If you don't want to use this, you can use this formula, and the formula is add all the true classification and divide by the all possible classification. It's like my accuracy score. Suppose you don't want to use the formula as well, so we have an inbuilt method for that. And how to call that method? We have already called that method. With the help of sklearn.matrices, you can import the accuracy score, right? So you can simply call this method as well. Now let's just call this method ACC score, accuracy score. And accuracy score generally needs the same value, y true and y predicted. So y true is like y test, and y predicted is like y predicted. Just simply run this, right? Again, you will get the same score, y test and y pred. And you know that the accuracy score is 100, right? So in the same way, we have three different ways to calculate the accuracy score. I hope everyone is getting my point. Candidate, is my screen is visible now? Just let me know. Can we calculate accuracy score? Now let me know which one is good one. Is the model dot score is a good one? That one is the basic one, right? You can simply calculate the score. This is a basic one. You can use the another approach that is called confusion metric score, where you need to calculate the confusion matrix. Then based on this graph, or like based on this image, you have to figure out which one is TN, TP, FP and FN, and then you have to unpack all the values. And then with the help of formula accuracy score, you can calculate the accuracy score, and then you will get the final answer. This is the second alternate approach. And the final one is the best one that you can use accuracy score as a like as a method. You can call this method and just simply give the y test value and y predicted value. It will run out this formula and it will give you the final score. So we have three different ways to calculate the accuracy score, and we have the fourth one also. I'll tell you the fourth one, right? The fourth one is the very good, like very easy one, right? So let's just calculate before just moving to the next score. Is there any doubt in this one, class? Let me know. Let me know if you got this point. Candidates Sarat, Apeksha, Taruna, Vijay, and other candidates, rest 22 plus more candidates. Let me know if you got this point. What is the use of a confusion matrix? In short, confusion matrix allows us to compare the model output with the actual output. And it just try to form a correlation between four possible values, right? True negative, true positive, false negative, and false positive. And all these false one are like the misclassification, and both true one are the like a good classification, or you can say the perfect classification, right? This is the use of this confusion matrix. Now, what about the rest score? So you can have a like reference of all the formulas, like accuracy score, precision score. Let me just write this. Well, no interval going to ask you write the formula. If you just want to like learn out all these things, you can have a reference. Like This one is the final formula, and we have already calculated the accuracy, right? You can just take a reference of this image, and let's just take a copy, and then with the help of this formula, we'll calculate all the scores, and we have each methods for each score as well. Now we have calculated the accuracy. The accuracy will try to identify where our model able to perform the exact classification. That one is my accuracy score. Now apart from this accuracy score, we have precision score as well, we have recall score as well, like specificity, and sometimes we also say recall as a sensitivity, right? So we can also calculate the F1 score, and F1 score is nothing, it's a combination of both precision and recall score, because there might be chances we are getting the tie between precision and the recall score. So in that case we can give a preference to the F1 score. So F1 score we generally use when we are getting the good accuracy, but we have different types of errors as well. There are two types of error. The first one error is called the type 1 error, and the second two error is called the type 2 error, right? And the interviewer also asked this question, the type 1 error and the type 2 error. Now let me just show you the first type 1 error and the type 2 error in the confusion matrix, right? And this one is very easy, right? You will get to know ki what exactly the type 1 error is and the type 2 error is, right? Suppose we have created a model, right? Now we know that we have different types of hypotheses. See, this is the first technical term that you need to understand. The by default true, or like the actual true, is called the null hypothesis. What is null hypothesis, candidate? Taruna, what is null hypothesis? Vijay, Vaishnavi, Apeksha. Like a null hypothesis is like the by default truth. Suppose the by default truth is like tomorrow will be a rainy day. This is my by default truth. Okay, based on some forecasting and calculation, I have calculated this. Yeah, I'll score 100% in mathematics. I have scored 100% in mathematics is my null hypothesis. So what is null hypothesis? Yeah, let's just take another or best example. Tomorrow the sun will rise, and we know that the sun will rise, right? That is called null hypothesis. So what do you understand by null hypothesis? A null hypothesis is like that is 100% fixed that this will be happen. Okay, that is my null hypothesis, and we have to reject this null hypothesis if we want to justify any other statement. That is called alternate hypothesis or reject null hypothesis. Okay, so we have a like actual truth, and we have like different truth that will reject this null hypothesis. That is called alternate hypothesis. Okay, so if we just forget this hypothesis and alternate hypothesis, let's just keep a basic example, and that is the type 1 error and the type 2 error. Suppose I have created one model that generally predicts the earthquake. Okay, so we have four different possibilities, right? Let me just write actual and the model prediction. And my model can able to predict whether the next day a chances of earthquake is or not, right? I have created a model, it can predict the earthquakes, right? So let's just take an example. On some day it was actually like an earthquake, right? And my model also say yes, it is an earthquake, right? The actually it was an earthquake, but the model predicted no, it is not an earthquake, right? In the actual scenario it was not an earthquake, but the model said yes, there can be an earthquake, right? That is the model prediction answer. And the actually there was no earthquake, but the model said there is no earthquake, right? Now we know that model predicted two times correct, and that is the actual was earthquake and the model also predicted earthquake. That is my perfect classification, and we know that we have already used this example, right? Perfect one. And this one is also the perfect one, right? Now we know that we have two different misclassification. The first one is this one and the second one is this one. Now we need to understand which one is the dangerous one. Can anyone let me know which one is the dangerous one? We have two misclassification. Actually, there was an earthquake, but model predicted no. This is also my misclassification. And the second one was actually there was no earthquake, but model predicted there can be an earthquake. Right. Now let me know which one is very dangerous like classification or like prediction. Can anyone let me know? You can just simply let me know the second one or third one, sir. Which one is very dangerous prediction by the model? That second one is like actually it was an earthquake, but model predicted no. And the third one is like it was not an earthquake, but model predicted yes. Now let me know which one is the poor classification or like the dangerous classification. Everyone is telling second. Why you are guys? Why the second one is the dangerous one? Because the actual it was an earthquake, the actual the patient has a cancer, the patient has like the TB, or the patient has like something any kind of diseases, but model predicted no. So the patient will forget and start enjoying their life, and this could lead to their permanent damage, right? In the same way, the actually it was an earthquake, but the model predicted no, and the people were like, okay, there are no earthquake scenario, so let's just be stay there, right? So this is a dangerous classification and or like a dangerous prediction. So we refer this as a type 1 error. And the type 1 error is like very dangerous for our model. We need to avoid this type 1 error. Okay. The more we can reduce the type 1 error, the better model it will be. Okay. And this one by default is a type 2 error. You just need to identify the type 1 error candidate. And which one is the type 1 error? Just let me know. The type 1 error, those who is very dangerous classification is a type 1 error. And what about the type 2 error? It is dangerous, but not up to that level of the type 1 error. Okay. So we need to identify the type 1 error. And it is like, since if we can rotate the matrices, the type 1 and type 2 error changes. So that is the reason it creates some sort of confusion, right? So null hypothesis is true. It means actually there was an earthquake, but model predicted no, right? So it was like some sort of kind of type 1 error. So you have to avoid the type 1 error, and type 1 error is very bad for model. So let me just write this. Type 1 error is very bad for model, ML model. We need to minimize the type 1 error. And it is also bad, but not up to that level of type 1, right? And we know that we have a perfect classification here and here as well, right? So all these scores or all these matrices generally helps us to identify the different levels of accuracy: precision score, recall score, F1 score, accuracies, and specificity, right? Now let's just start with the precision one, then we'll understand the definition. How to calculate the precision? Let me just write the pre-score instead of precision. And we know that the formula for the pre-score is like TP divided by TP plus FP. And we know that where is the TP? TP divided by TP plus FP. You have to take like this. Now we know that we have all the positive classification, and inside this positive classification, what exactly the true classification? We have, see, you need to check total. We have like some sort of the customers that they are likely to buy the insurance. In that particular set of customers, how many exact customers that model has predicted yes they will buy the insurance? These are like my perfect prediction. So you can say these are the precision scores. The precision scores are like in the positive scenario, what exactly the model has predicted the positive one is the positive, or like is the precision score. So the formula is like TP divided by TP plus FP. So you can just simply calculate pre-score is equals to TP divided by TP plus FP. And we know that you can simply run this pre-score, print this. That one is your precision score. And we know that because there is no such like false classification now, because the FP is 0. Here is the FP is 0. So we are getting TP divided by TP plus FP. It means 12 divided by 12 plus 0. It means 12 divided by 12. And that is the reason we are getting 100% accuracy or like 100% precision as well. So if like 12 customers were likely to buy the insurance, and model also said, yeah, 12 customer will buy the insurance. So there is no such misclassification, and that is the reason we are getting the highest precision, or it means the model is very precise. It can 100% predict, or it can predict with the 100% precision if the customer will buy the insurance. That is your model precision. In the same way, you will get each value as 100%. Why? Because we don't have any false classification right now. And I'll give you the data set where you will get some false positive and false negative data as well, right? And then you need to calculate all the scores, precision, recall, FN score, and so on. Now let's just calculate the recall score. Okay, before calculating the recall score, let's just use the yes. Let's just calculate the recall directly. REC score, and it is like the formula is TP divided by TP plus FN. FN. So TP divided by TP plus FN, like in the overall scenario of the positive and the negative one, how much or like how much data model can able to truly classify. That is your overall recall value. So it's like TP divided by TP plus FN. See, you cannot learn or mug up all the formula. You can just have a reference, or you can just take a reference to print out or like to get all the values, right? So it's like TP divided by TP plus FN. That is your recall score. And let's just run this. You'll again get the 100% score because there is no such false negative value. And you can use the method as well to print out the recall score. And we know that if we want to use the method now, you have to use this one, y test and y pred, and you will get the recall score as 100%, because we don't have any misclassification data right now. If we are getting every score as a 100% score, it has two meaning. Either the model is overtrained, either the model is overfit, or the data set is very neat and clean, and the data set is that much level of clean so that the ML model can easily identify the pattern. Okay, but in the practical scenario, you are not going to get every score as a 100% score. I think is that clear, right? Okay, candidate, is there any doubt related to as of now? Precision is equals to TP divided by TP plus FP. Yes, precision is equals to TP divided by TP plus FP. See, you don't need to like mug up all the formula. You just take a reference. You can simply say the meaning of precision. The meaning of precision is like it can simply identify the actual classification based on the overall classification of the positive result. Okay, it's like TP divided by TP plus FP. If you just try to learn or mug up the formula, na, definitely you will forget, right? So just take a reference. You can just simply say, I'll take a reference of that, right? You have to understand the concept, right? If you'll do it practice multiple times, definitely you will understand the formula as well, right? Now let's just calculate the specificity. Specificity is like how much the negative data. It's like completely based on the TN. TN is like the negative classification, or like the customer will, that they are not going to buy the insurance. It's like the true negative data. So you have to pick the true negative data based on this FP result, right? Based on the FP result, right? Specificity. So you can just take a reference of this. On overall negative data, we have like two negative data. The first one is like the TN, and the second one is like the FP. And why we are considering this as a negative? Because it fall under the negative one, but the model has classified this as a positive data, but actually it should be inside a negative one, right? So how to classify the specificity score, or how to get the specificity? You have to just divide the TN by the overall value, TN plus FP. So let's just calculate the score as well. SPEC score is equals to TN divided by TN plus FP. And you can run this. And again, you will get the 100% score, right? Is there any internet issue? Guys, are you getting my voice now? Because this cell got like took almost more than it should be time. That is the reason I'm asking this. Okay, now we are getting the 100% score. Now, see, why we are using this F1 score. If there is any confusion between the type 1 error and the type 2 error, and if we are getting the 100% accuracy, but there is some sort of confusion between precision value and the recall value, and the precision and the recall are same, then in that case we will give the preference to both precision and recall. And there is another score that is called F1 score. F1 score is just nothing. It's just a two times combination of this precision and recall score and their overall value, right? So you can just simply say precision multiply recall and divided by their sum, and just keep it two times, right? That is your F1 score. The more you will get the F1 score, see, just understand this formula, right? When to get the F1 score on higher side, we have to minimize the precision plus recall value. The more we can minimize the precision plus recall value, or we can maximize this one, we'll get the F1 score on the higher side, right? So you can just simply calculate this F1 score. F1 score is first two times of precision score, and we know that precision score is pre-score multiply the recall score. Recall score is REC score, and simply divided by the sum of their values. And we know that the precision score is 1, recall score is 1. It's like 2 multiply 1 into 1, it's like 2. And if you just simply divide it by 1 plus 1, it's like precision score plus recall score, it's like 1 plus 1 again will become 2, and 2 divided by 2 is like 100%, and you will get the F1 score also as 100% score. You can just simply run this and you are getting the np dot float. It means 100% of score. And instead of direct calculating this, you can use the F1 score formula, where you can simply give the y actual data and y predicted data, and you will get the F1 score as 100% as well. Now the problem with all this one, if you were doing like your graduation or bachelor's in data science, AI and ML, then this is the part of your semester questions where the college faculties will ask you just derive all the formulas or calculate all the result or like all the accuracy scores and all the matrices, right? Because we are directly learning it for the industrial perspective, so there is no need to like mug up all the formula. You can just have another method that is called classification report, and this classification report generally print out all the value, where we no need to calculate the each value one by one, but it is recommended to understand each value and to calculate each score one by one, so that you can understand it well, right? We have another matrix that is called classification report. What you can do, you can simply print out this classification report, and you no need to calculate each score one by one. And how to print this? Again, you have to give the same parameter, that is y test and y pred. Once you give this, you need to pass this inside a print function, right? And let's just pass this inside a print function, and you are getting the multiple values or like the multiple score at once. Precision score, recall score, F1 score, and support. And what is that support? Support are like these values. We are getting two supports now, true negative and true positive. That are my supports value, like 5 and 12 are like supports. And that is the reason you are getting this 5 and 12 as a support. And the final support will become 17. 12 plus 5 is 17. That is your macro average or like weighted average. And you're getting each score as 100. It means the model is overtuned or like model is very perfect. Since the data is very less, so you can say the model is overtuned right now. Okay. And the model is able to predict the zero class with 100% precision as well, and the one class with 100% precision as well. It means model can predict on both sides. It can give you whether the customer will not buy the insurance and whether the customer will buy the insurance or not. It can give you both values, and that is called predict probability. Now let's just calculate the predict probability, and let's just build a model where we will take a input from the user, and that input will be transferred to the model, and model will just say or like just predict whether the customer will buy the insurance or not. Okay, now for just dummy purpose, let's just take a name of the customer. Now we are creating a function, and that function will generally predict whether the given customer will buy the insurance or not. Okay, before directly creating this function, let's just understand the different inputs that we need to take. We need to take multiple inputs, and they should be like their age value, gender value, salary value, credit score value, previous claim, and the metal status. And the age and metal status should be in 01 format. If you want to take it in a textual format, then you have to convert this inside like in a numerical format. Okay, so what we'll do, we can simply give a prompt at the input level. If you want to like enter male, so you can just write 1, and if you want to enter female, you can write 0. We can have an input like this one. Okay, so now let's just okay, instead of copying this, let's just take a reference of this x column, and we'll create a input function based on that. X dot columns. All these are my columns, right? Why I'm not getting the columns? Okay, the problem could be like this because it was a small x. That is the reason. Okay, now we have the all columns, and we'll take an input for each and every column. So let's just take a name. Guys, are you getting my point now? And the function is like predict insurance. Okay, we'll just simply take an input on the behalf of a customer. Okay, And let's just take input in some sort of manual hard coding, and it is like input, and it should be in a float manner. The type should be float because the user can give the any values from 0 to 1. Okay, and we can say enter your age. If you just want to like apply a constraint now, so you can just simply say between 18 to 60. This is the constraint, right? Enter your age. Now we are just simply converting this input to the float value, and that one is my age. Okay, and the second we'll get the gender. Again, you can use the input, right? And let's just convert this to integer. Why we are converting this to integer? Because we know that we just only take input as 0 or 1, and before directly taking input as 0 or 1, let's just check which one is 0 and which one is 1, right? We have used the map methodology now, so we can just simply check the female one is 0 or like the male one is 0. Okay, the male one is 1 and the female one is 0. Okay, so let's just take the same reference, and you can just say enter your gender. Guys, we are creating a predict function that will take an input and will predict whether the customer will buy the insurance or not, right? Enter your gender, and you can just say male, you can just write 1, and for female you can just write 0. Guys, are you getting my point now? Is there any doubt whatever that we have performed so far? Just let me know, candidate. Anas, Apeksha, Sarath, Tejaswini, Taruna, rest candidates. In case of any doubt, just let me know, right? The third input is the your salary, right? So you can just take an input of salary. Again, you can create. See, we can run a loop as well, right? If we want to develop a website now, I would rather prefer to run a loop rather than creating this one, right? So let's just hard code right now the float value of salary. You can again take an input, and you can just say enter your salary like this one, SALARO, enter your salary. And the fourth one is your credit score. And you can just convert this to float or integer as well. There's no such issue. Well, it's recommended to use the integer because we know that there is no like 65 point something kind of credit score, right? It is in a round or like a whole number. So you can just simply take it as a integer, right? Inside this input, enter credit score. But in the practical scenario, candidate user will not enter the credit score. You know that now the company or like the bank will automatically fetch the credit score. Is that clear? Guys, are you getting my point now? I hope everyone has seen that the user will not enter their credit score, right? The company will automatically fetch the credit score based on their civil score, right? That is called the civil kind of something this. So the company or like the bank will automatically fetch. Since we don't have that much level of access right now where we can simply fetch out the credit score. So that is the reason we are simply getting the input from the user, right? So enter credit score, and the second last is like the previous claim. And again, you can convert this to integer and then followed by the input. Enter claim status 0 or 1. Okay. 0 means no claim, 1 represent yes. They already claimed the previous one. And the final one is like the metal status. So let's just write this as a MS. MS simply is like the metal status. Enter metal status, and again 0 or 1. 0 represent no and 1 is like yes. The person is already married, right? Now, once we got all the data, what you have to do, you can just simply turn out this data into a complete nested list, right? So that it should be in a 2D or like a two-dimensional, because the model only works with the two-dimensional of the feature, right? So let's just convert this into a features, and you can have a features like this because we are not running the loop now. So you have to print out all the values like this one, and you just keep the same sequence, the age, gender, and then salary. Now just imagine the problem where we are getting multiple features. So we are not allowed to use this approach because this was the dummy approach. Since we have very limited column, na, that is the reason we are using this. Now just imagine if we are getting 50 number of column. then it's not mandatory to create each individually, right? We can run a loop. The fourth one is credit score. The fifth one is previous claim, and the sixth one is metal status or like MS. Okay. Now, once we are ready with the feature, okay, instead of feature, na, let's just convert this to user input, right? This one is good. Now we know that we have to pass this user input inside where candidate. We have already created a model now. You can just simply pass it inside a predict. And predict method generally pass these like take this data and it will give you the answer in a array format. And you can store it inside answer. And the answer is like in a single like a one-dimensional array. So you can just simply slice it those value and you can just have a print Naman, like whatever the name it is, okay? And you can just say if the answer is like one, so you can just have a print like this F string name, like whatever the name it is, like Aman, Karan, Nayan, Apeksha, so and so on, will buy, ya can buy the insurance with, you can say probability as well, with probability of something like this. Now let's just calculate the probability as well, okay? So you can just say PREDICT, that is called predict probability. Okay. And how to calculate this predict probability? You have to use this model dot predict probability. This one, right? And you have to give the data as well, right? The same data. Okay. And now just simply, okay, instead of this predict probability, now let's just convert this to PP. And we know that the PP is nothing, it's a predict probability. So with a probability of something like this, okay, this one is like if condition, if the answer is one. Now, if the answer is like zero or like if the answer is false, so you can just say like any name can buy instead of can buy, yeah, will not buy, will not buy the insurance with the probability of something this. Okay. Now let's just create this function. Now this function will take a name and the rest detail and it will give the final value. Now, how to run this function? You can just simply give any name. Let me just take a name like Jatin. Now it will ask, okay, you can just also say na enter, yeah, hello Jatin, enter your age. Okay. If you want to predict, you can enter your age as well. Let me just take age as 23. The gender is male. Salary is some sort of like this 45,000. The credit score lies between like 780. Oh, that was the mistake, right? Now we need to see. I hope everyone is familiar with the exception handling, right? So you can just manage it. Okay. Since like I have by mistaken entered some wrong values, that is the reason I'm getting the value error, right? Now I need to again run the code. So instead of this, what you can do, you can use some try exception handling. I hope everyone is familiar with the try exception handling. Guys, are you getting my point now? I hope everyone perform already the try exception handling to just handle the error at runtime, right? So you can use the try and exception handling. Now just let's just rerun this code. The age is 23. Let me fill it. The salary is something like this 45,000. The score is like 780 and the claim status is zero. They have never claimed, like Jatin has never claimed. And the metal status is one, and it is say it is like the Jatin will not buy the insurance with the probability, and we are getting something like this, right? So instead of this candidate, what we will do, because the probabilities, see, we will get the two possible probability. The first is on zero side and second is on one side. Now what you have to do, it will try to calculate the both probability, right? This is the behavior of machine learning or like any deep learning concept. Now you have to check the maximum value. So you can just simply say dot max. And once you say dot max, it will calculate the value and let's just multiply the value with the 101 so that you will get the value in a percentage format, right? And you can just simply write the percentage sign here as well. Now let me just run it again. Jatin. Okay, so it was a age, right? The age was like 34 and it is 1. The salary is something like 56,000 and the credit score is something 780. the claim status was 0 and the metal status was run 1, and it is like Jatin can buy the insurance with the probability of 1. Now you can just check, because I have changed the claim status from 0 like from 1 to 0, so it is like it will buy the insurance. It is perfect na, because if someone is already claiming, it means they have their insured amount, right? If someone is not claiming, it means it might be possible that they are not insured, right? And that is the reason I'm getting the value like this. Jatin can buy the insurance with the probability of 100%, or instead of can, you can just say Jatin will buy the insurance with the probability of like this one. Okay, you can just also write the percentage sign here. Now candidate, we have built a model, and you can use this predict function to take a input from the website part or like the front end part, where the user will enter all their details at the website form, and that predict model will predict the answer. Now let me just try some with random values. The values, the age values is like 56, the gender is male. Let me just reduce the salary to 20,000, right? And the credit score is 450. Now I know that the credit score and the salary is very less. And let me just change the claim status to 0 and the metal status to 1. And it say the Jatin will not buy the insurance. Now what could be the possibility, guys, that we are getting the Jatin will not buy the insurance? Just let me know. Just let me know, according to you, what could be the possibility that we are getting Jatin will not buy the insurance? It could be like low credit score. It is due to, like, it can be due to the low salary score. Yes or no? Anas, Apeksha, Taruna, Vaishnavi, other candidates, guys, just let me know na. This could be the possibility, right? Due to the low salary, the low credit score, and that is the reason Jatin will not buy the insurance. The possibility due to the low credit score or like the low salary. Now let's just change the Jatin to Mahima, and Mahima is like the female customer, and the age is some sort of like this. If anyone wants to try some dummy data na, so simply just send the message inside a message box. I'll copy that message. I'll try it here. If anyone wants to run this, I have already shared the screen. They can create a copy. Now let me show you how they can create a copy. They can go to this file option, click on this save a copy on copy in drive, run your own code, and just try it with all these dummy values, right? So this time the gender is 0, the salary is some sort of like this, 55,000, and the credit score is very less. Let me just take the credit score is very less, right? And the claim status is 0 and the metal status is 1. Now it says the Mahima will buy the insurance with a probability of 100%. And that's where a human interference is required, because human involvement is also necessary, because according to model, it gives the preference to salary, claim status, metal status, but it's lacking with the credit score, right? Because the salary is good, the model will try to understand, okay, the Mahima can buy the insurance, right? Now let's just reduce the salary. I'll keep the age value as same 0, and the salary bracket is something like 30,000 or 23,000. Okay, and the credit score again very less, and the claim status is 0 and the metal status is 1. Now see, again we are getting the Mahima will buy the insurance with a probability of something like this, 99 point dot 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 dot. Okay, you can do one thing, you can directly round off the values, right? Instead of directly using this now, you can just simply round off the values so that you can get the up to 2 decimal place, right? So can it, in this way we can create a model, and that model can predict the values. Okay, now let's just take the age as 20, uh, 0, and the salary is like 55 or like 60K, and the credit score is some sort of like this 780. The claim status is 1 and the metal status is 1, and it's a Mahima will buy the insurance with the probability of some sort of like this. Okay, I hope everyone getting my point, right? Tejaswini, Apeksha, anyone wants to try this one? So candidate, in this way, we have completed like this logistic regression and implemented a project as well at the very basic level. See, we can turn out this project into a web development level as well, but you can just understand with the some sort of basic coding how many things that we can perform, right? These are the power of this Pythonic approach, right? Just only with the help of Python we can turn out this very basic data like this one, we have also performed some sort of like exploratory data analysis, and this is the actual approach that a data analyst or like a data scientist or like an intern or like a junior data scientist or some sort of a fresher can prefer this kind of approach to understand the data, to turn out the data into the textual to the numerical one, to get insight using the EDA, okay, to figure out the correlation, to check the feature engineering approach, right, to identify the correlation, then turning data into like the meaningful analysis, then converting data into X and Y part. And once you convert this, you can divide your data train test split, you can call the model, you can predict the value, you can evaluate the model using the different evaluation matrices. And if we are performing the classification part, we have different sort of matrices score as well. You either you can directly import this, or you, with the help of confusion matrix, you can create it your own as well, right? Since we are using the multiple approaches, so first we completed with the confusion matrix approach, where we need to understand the flatten concept, where we'll get the TN, TP, FP, FN values, right? And all these are the score that generally evaluates the classification, or like the logistic regression final output, right? See, the logistic regression is not only limited to the binary classification. Let me be very clear, right? Although I have written this, that logistic regression generally used with the binary one. I hope everyone is getting the point, right? I've written this. It mainly used for classification problem for the binary one. Why I'm saying this? Because this logistic regression is the foundation block of deep learning when it is comes to the binary classification. Okay, and that is the reason, because whenever you are dealing with the neural network, there is a concept which is called activation function. Each single neuron has their own activation function, and activation function generally built with the help of a logistic regression. It's a binary classification, not with the logistic regression. It generally would be built with the sigmoid function, and we know that sigmoid function is just nothing the foundational block or like the mathematical block of this logistic regression. That is the reason we are saying this. It mainly used for the binary classification, but it's not the final fact. You can use this for the multi-class classification. Now, candidate, I'll give you the data, okay, and apart from this, now this time you have to use the multiple classification approach, okay. Now just do one thing. This is the data set. In the next class we'll start with this one, and that is called multi-class classification approach, and we'll start with the another model as well, okay. I'll first teach you the next model, that is like it could be like SVM or like support vector machine, or it can be a decision tree as well, right? So I'll teach you the another model, and based on that model you can predict the numerical like the regression part as well, and the classification part as well, right? With the help of logistic regression, you cannot predict the numerical output or like the linear regression kind of solution. If you want, you can do it, right? But regression is generally built to get the numerical output, and same with the logistic one, right? So in the next class, we'll start with the multiple or like multi-class classification. Instead of multiple, let's just say this as multi-class classification, and here we solve a problem of digits data set, and these digits are like handwritten digits, and the digits are something like this. We'll try to create our own handwritten digits, okay. We'll convert the digits into the numerical values. Numerical values are like the values ranging from 0 to 255. These are the handwritten digits. We'll give the image format data, and we'll understand how this image going to be like interpret in a machine learning way. And once machine understand all this image data in a numerical form, then we'll create a model. And once we create a model, we'll give an image like this. And once giving the image, like after giving that kind of image, a model should predict what exactly this digit is, right? Now just let me know your approach, which digit it is. It's look like 8, right? So you the way you have predicted now, the model has to predict in the same way, right? So we'll use that like approach. And sometimes we also refer this as a handwritten digit, or like MNIST data, and some sort of like this, okay. And this is like for the multi-class classification. Now it's your homework. If you just want to try, let me just show you. You can just simply do one thing from sklearn. you have this concept that is called dataset. sklearn also provides some dataset. From sklearn.dataset, you can simply import the load digits, right? You can just simply write the load digits and you can simply load the data, right? Once you load this data, na, you need to convert this data into x and y part, and then probably you can build the logistic regression model as well as to predict the multi-class classification, right? If you're not aware with this concept, so no issue, we'll simply sort out all this one in the next class. Okay, now just let me know any doubt or any question related to this one, candidates. Apeksha, Anas, Vaishnavi, guys. See, you can practice it multiple times, right? And the companies are generally interested because we are going towards the vibe coding era where we generally rely on the agentic AI. There is no need to hardcore such thing. You just need to understand the concept. Believe me, there is no use of all this kind of coding in current era, but you have to understand this, how to write this kind of code, at least with the help of Gemini or like any chat gpt integration. If you're not good to go with the coding understanding, then you cannot particularly use the chat gpt or any llm model up to that level. Okay, in the upcoming era we are not going to write a single line of code that the way like the way that we are doing right now. Okay, the coding industry completely going to change. Now what you have to understand, you just have to understand how to write code, how to quickly understand the code. You don't need to write the code from scratch. You just need to understand what code exactly can be interpreted in what way, right? This is the actual understanding that you need to develop. Okay, in the same way, if you understand this, you can start with the machine learning, deep learning, followed by the natural language processing, generative AI, LLMs model, and so on, right? Then you can probably plan for the agentic AI or like AI agents, and then the large language model with the help of LangChain, RAG network, generative adversarial network, GAN model, and so on. We have multiple things, right? And this industry is completely right, change the entire market. So I'll just suggest to take a complete overview of everything. No need to rely on hardcore code of everything. If you just, if the interviewer will say, okay, let's just create a model in front of me, it's like they were just checking you, right? So you can just take a reference. I just only know the things. You can just try multiple things from your side and just do it practice as much as you can, right? So this is from a side candidate for today. And if you have any doubt, just let me know right now. Otherwise, I'll close the session. Vaishnavi, Taruna, Sarad, Preeti, Nanthala, Apeksha. Okay, and the common thing that guys I have observed, you guys are just listening, right? Huh. Don't you have any questions or any queries or any sort of doubts? You guys are just listening in just one way, right? Tejaswini, any question, Anas, Apeksha, and other candidates? Let me just check the list of candidates. Neha, Pragna, Prajwal, Preeti, Priya. They try to be more engaging, right? If you ask a question, then it would be more like good for the rest candidates so that they can understand something new, right? Even I know what to deliver, right? If you just ask multiple question, you will definitely help your like other colleague or friend to understand the things in a proper way, right? So let me just close this session again. I'll repeat, if in case of any question you can let me know. And the code notebook is same. I'm using the same code notebook since last 3 days, right? Because the classification problem, and I'll use the again same notebook for the next class as well, so that we'll completely understand the classification portion in the single notebook, and it will definitely help you to quickly take a recap of this, right? And you can build your own model as well with the same code of reference, right? And the second thing is, I'll give you some data. Now give me time for today. You'll get your data by the end of by the like late night today, right? So let me just close this session, candidate, and wish you all the best. Let's meet tomorrow, right? Bye bye.